everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this integral of dy over dt all squared plus dx over dt all squared. All these expression inside the square root, and we have dt. We were told to find the integral of this expression considering that x is equal to Euler to the power t times cos of t, and y is equal to Euler to the power t times sine t. Okay, first one we check is like we have the derivative of y, which respects to t, and we have the derivative of x, which respects to t. This is not second derivative because we have to be careful in this case. We have always to know that this denotation in maths is not the same as this one. They're not the same. This one is first derivative to the power n, and this one is the nth derivative. Could be 3, 4, 5, 6. So that means for n equal to 2, for example, this will be the first derivative all to the power square, which is the case that we are given. And if there was 2 here, that will be second derivative. So when the exponent is by the d, that means the order of the derivative. But when the exponent is outside, that means all that derivative squared. Okay. Perfect now. So considering that, then we have the value of x, we have the value of y. And this expression, why don't we find the derivative of y in which respects to t first? So having the value of y, this means then the derivative of y in which respects to t, from here, we can apply product rules, which we know that for the product of two expressions, if we're finding the derivative, it's the first one derivating times the second one plus the first one times the derivative of the second one. Okay, now if we apply it here, the derivative of Euler is still Euler, so it will be Euler sine t plus Euler does not derivate, and the derivative of sine will be cos, so cos t. Okay, now we can find the derivative of x in which respects to t, which will be the derivative of Euler is the same, so Euler t cos t. And the derivative of cos will be minus sine, so which will be minus Euler to the power t sine t. Okay, now if we check in our problem, they said the first derivative of y in which respects to t, it's all to the power 2, so it's squared. So let's square this expression, and consequently we will have to square the right side also because they are equal to find what's this what's the square of the derivative of y in which respects to t. Okay, so this implies in this case that dy over dt squared will be equal. If we square this expression, we just have to remember a plus b squared is equal to a squared plus 2ab plus b squared. So if we apply this approach here, this is our a and this is our b. So we're going to have a squared, which is Euler to theta, sine squared theta, plus 2ab, so which is sine theta and cos theta, plus b squared. Okay. Now for the second one, we have dx over dt all squared, which will be similar, but this one is for the negative. So we'll have Euler to the power 2t sine squared t minus 2 Euler 2t sine t times cos t plus Euler 2t cos squared t. Now if we check inside of our square root, they say they added both of them. So we have this expression, we can add them. So if we add them, what are we going to realize? These two expressions, they are symmetric, they're gonna cancel out. So these imply that dy over dt squared plus dx over dt squared will be equal to, this one are cancelled, this one are the same, we will be 2 times the same one expression, and this one are the same also. So this will be equal to 2 times Euler to the power 2t times sine squared t plus 2 times Euler to the power 2t times cos squared t. Now what happened is we realized that we have 2 and Euler in both expressions, so that means we can factorize. So if we factorize 2 Euler to the power t, we're going to have, we can put brackets here, so this will be plus cos squared t. Okay, if we factorize 2 Euler to the power 2, if we look, sine square of an angle plus cos square of the same angle, according to the fundamental trigonometric form, this is always 1. So that means this expression will be 1. So if this expression is 1, we only left with 2 Euler to t. So that means this expression that we have inside the square root is equal to this expression. So that means this integral will be the same as calculating the integral of square root of 2 Euler to the power 2t dt. This dt is this dt outside here. So we're going to have, this is the same as square root of 2 Euler to the power t squared, and we can separate the square root, each one with the square root, 2 with its square root and Euler with its square root. So square root of 2 is constant, can come outside, integral. These 2 can cancel with the index, so Euler to the power t dt, this will be equal to square root of 2 times. The integral of Euler, we know that it's Euler, so it's going to be Euler t plus c. So this is going to be the solution for this given problem. Okay. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.